Hello, this is JoeG. My final project for Predict 454 is Rossmann Store Sales Challenge. Rossmann operates over 3,000 drugstores in 7 European countries. Our goal was to predict 6 weeks of daily sales for approximately 1,100 stores in Germany. Sales were influenced by promotions, competition, holidays, locality, seasonality, and 1 million rows of data was given to us. The response variable is the store daily sales. Other data included number of customers, store open close status, holidays, competition open date, competition distance, and store promo schedule. The competition specified that the submissions were evaluated on the root mean square percentage error, which required us to build a custom function to evaluate performance. We leveraged some kernels, some pretty nice kernels in the competition here to build our own EDA, and it turned quite pretty nice. So the sales distribution was quite skewed to the right, and then we chose to use a log transform variable to alleviate this. Um, the training data included approximately 17% of closed stores with zero sales, so we removed them from the training set as we wanted to predict positive sales and also to avoid misbehavior of our evaluation metric. Customers has a Riley skew histogram with a mean of 763 customers per day when the store is not closed. The plot between sales and customers shows a positive association between sales and customers, but customers are not in the test set, so we'll not include it in the model. Promo indicates whether a store is running a promo on that day or not. The plots show sales versus promotion and customers versus promotion. And it suggests that sales are higher when stores are on promo, but traffic, which is the number of customers, does not increase as much. In fact, sales increase about 1.24 euros per customer when the store is open and on promo, but the average customer increase is negligible. We have two different types of holidays in the data set. One indicates a state holiday, and the other if the store was affected by a school holiday. We noticed sales are highest during Christmas and then followed by Easter and public holidays. And when we look on the bottom right chart, we see school holidays do not impact sales that much. Another variable is assortment, which basically describes the assortment level on the store being A, basic assortment, B is extra assortment, and C is extended assortment. So we notice that the store type B that carries assortment C has the highest sales. Also that store B carrying assortment B has the highest growth. On the right part of the chart, though, we notice that the customers trend by store have a very similar behavior on the sales trend by store on the left. Competition distance is the distance in meters to the nearest competitor. We noticed that 50% of the competitors are located less than 2.3 kilometers of distance. And looking at the plots in the bottom, we see that competition, the closest the competition, higher the sales, which seems a bit kind of strange, but we thought it may be due to city locations having higher traffic of customers and being the cause of that phenomena. So competition open since is a variable that gives the approximate year and month of the time the nearest competitor was opened. So the histograms uh, help us to see that, and we calculated the average competitor open in 2009, and there is a funny one competitor that opened in 1900, which we did not discard that, but it could be an input error. So the last variable I want to talk about is the promo interval, which describes the consecutive intervals promo is started. Um, so for example, Feb, May, August, November means each round of promo starts in February, May, August, November of any given year for that store. The plot in the bottom shows stores or suggests that stores with promo 2 tend to make lower sales, uh, but that doesn't necessarily indicate that promo 2 is not effective. But in my understanding, it simply could be that stores that adhere to promo 2 may be less effective or less efficient stores. All right, so missing data and feature creation. So we had first several attempts. We tried to use the mice package, but the imputation didn't result in a good score. So we end up aborting that route. The missing values were predominantly with promo distance and open since, and we end up replacing the missing values with, instead of 0, we put a negative 9999, which is one of the techniques that I've learned in the past, and it seems to work kind of okay. We also created variables. I think was like 7 different variables uh, that from holidays. We added more additional holidays. Days since the competition opened, we create this computation. We derive that from the data set. Days since promo started, the date, the day of the date, the month of the date, the year of the date. We strip those information from the date, and also strip the year, month, and the day, and create a numeric variable as well. So we decided to run a series of regression models and use the caret package in R. Caret, it's pretty interesting. It supports over 238 different models and has a great appeal for machine learning. So as part of this project, we also explored the H2O implementation for 2 models. And it's new for me and absolutely impressive. So we will compare that later. So gradient boosting with caret, we used basically a grid search approach first to estimate the optimal set of hyperparameters. And we use the cross-validation 5-fold, and with a partition of the data in order to identify general tendencies. So in the chart on the left, we see the results of many combination of parameters from the grid searches. And within each panel, the RMS-PE values are also shown. So then we use an instance of R on a server, and then we fine-tune the combination of these parameters using cross-validation within smaller ranges. We end up selecting 10 for the interaction depth, 1,000 for the number of iterations, 0.1 for shrinkage, and 6 for the n min obs in node, so which is the minimum number of training set samples in a node before commencing splitting. And then on the right, we see the variable importance. For the first one is the competitor distance is the most important, followed by the store and promo. The XG boost with caret, we also had to tune The hyperparameters is much more complex than the other tree-based models. So we end up having to partition the data using 30% of the data set prior to perform the tuning because of system performance issues. And then we fine tune it later using the server instance. So we selected 13 for the maximum depth, 2 for the minimum child weight. Also for the subsample was 0.9 and 0.7 for the column sample. And you can probably read the rest here on the slide. In terms of variable importance, we see the competition distance was the most important, store second, and followed by promo. We also see a chart showing, the performance on the train and test set as a function of the number of rounds, showing that about 1,000 is 1,000 rounds. It's you got stabilizing the air. We also use the lasso with caret and the cross validation with the GLM net function to select the lambda, the optimum value of lambda. We got 0 actually, the best lambda with a 0.47 RMSPE. Giving us the most important variable is store type B, followed by promo and assortment B. This was not a very good model, as we're going to see later. All right, random forest and ranger. So the performance of random forest is a bit inferior than the other ones, tree models we talked before, but it's simpler to train and tune. But the processing speed depends on the package implementation, so it was very, very slow. So we decided to tune Ranger with caret, which is a fast implementation of random forest. So for tuning, we again use 2 approaches to estimate the optimal set of hyperparameters. The 5-fold cross-validation and the 30% partition of the data to identify the general tendencies. And then we fine-tune that with a complete data set. For the M-try, which is the number of variables to possibly split in each node, we selected 25. The default is the square root of the number of variables. For splitting rule, we selected extra trees. And for minimum node size, the default is 5 and we selected 3. All right, then we did a random forest with H2O, which is pretty fast, scalable, easy to implement. However, to use a custom function, we would need to add a new metric to the H2O Java source code and then compile it, or put a feature request to the H2O team, which is a little bit beyond the paper. So we end up using the RMSC function as evaluation function. So for tuning the parameters with H2O is not that difficult at all. We end up choosing 200 trees. The default is 50. And we let the early stop criteria, which we chose to stop feeding new trees when the 2 trees average is within 0.001, kind of like a convergence setting. And as we can see here on the scoring history chart on the left, we end up getting convergence with a little over 30 trees. In terms of variable importance, we see that promo is the top one, followed by competition distance and store. All right, the last model that we trained was the deep learning with H2O. And the central idea is to extract linear combinations of the inputs as derived features and then model the target as a nonlinear function of these features. Um, so for the speed, we only train the first 10,000 rows of the training data set, and we scan the full um, Cartesian product of all combinations is specified in the grid search. So we train networks with 2 and 3 hidden layers with 64, 10, 5, and 2 neurons. As you can see here on this table, uh, that provides the 64, 64, 64, 3 hidden layers, 64 each, with input dropout ratio of 0.05 and rate 0.02. That gave us the lowest evaluation error. So you can see the epochs converging about 50, and also the variable importance, the highest variable importance as the competition distance, and followed by the competition year, month, days of difference. So this is basically the days since the competition opened, and store the third one. All right, so our top performing model was the XGBoost. Um, so we can see that our kernel was ranged 1333th out of 3300, so putting us on the 40th percentile, with the leader score 0.089 and XGBoost 0.11205. All right, and finally, I think there is a potential to improve performance if we focus more on the feature engineering and dealing with outliers and potentially missing values. I try to focus on mastering the new methods of Carrot and H2O. I spend a lot of time on that, which I really appreciate. Carrot actually proved to be a very efficient approach for running several different methods with a similar syntax. H2O, very fast, impressive, but it lacks easy custom evaluation function implementation. Again, this was very fun. Had a good time, learned a ton, and we were able to predict 6 weeks of daily sales for 1,100 stores located across Germany. Pretty happy with it. Thank you all for watching.